Oh, well, thank you, Alan Adams. I appreciate this one today. I had not seen this one yet, and I guess I missed it while thumbing through the MIT OpenCourseWare. Now, again, this is somebody you will see
The following content
fairly
is provided under a
frequently
Creative
in my
Commons
work.
license.
Usually,
Your support
in
will
my
help
work, because
MIT
this is super
OpenCourseware
critical.
continue to offer
Man,
high-quality
understand where I'm
educational
going.
resources for
I
free.
know a lot of people
To make a
get
donation
get
or to
locked
view
up in the
additional
stone mill
materials
for
from
me,
hundreds of MIT
and
courses,
in a way that's
visit
great
MIT
because
OpenCourseware
it's the
at
facts of life. It's a photon, it's an electron, it's a positron, right? So incompetence scattering to being one of the big words I finally understood the other
Today's
day.
task is going to be to outline
Yeah,
some
just
of the
got
basic
my first class in
facts
college
that
psych.
we will
Yeah,
both
fucking
have
bro.
to deal with, and that our aim should be to understand
So,
and model through the
model
rest of the course.
would have been my first set.
Physics,
My first set is
doesn't tell you some
I had a
abstract
couple of
truths
drinks at the
about
bar
why
last
the
night,
universe is the way it is.
and
Physics gives you
so
models to understand how things work and predict what will happen next.
and for me,
And what we will
models
be
make
aiming
that
to
really
do
well.
is develop
Sometimes you
models
get
that give us
so
some
many
intuition
of
for the
them
phenomena
that
and
you
allow us to
you
make
really
predictions.
can't,
And
and
these are
things
the
fall to the
experimental
atommost
facts that we'd like
in
to
a hurry.
explain, develop an intuition for, and be able to predict.
So, generally, like I said, the models for the bar are the facts of life. The models for the mill are the facts of life. The models for the
Start
bar
off with,
are also the
so let me
facts
just
of life.
outline them. So
We can do
first
things
fact,
like
atoms
take
exist.
overhead of Hancock and
Arguments
scale
about
by
randomness
any
is
quadrant,
definitely present in the
right?
world.
We
Some
can
spectra
take
are
the
structured.
atoms
We have
exist.
photoelectric effect,
That if I
which is
take
detailed.
this grocery
Electrons,
store, I take this stone mill,
do some funny
and I
things,
say that there's an
like
electron in
and
position around the
finally,
snowflake,
Bell's inequality,
randomness is going to
that we will come back
exist.
to
I don't
very
know
end of the
which
class.
of these is going to come
Would
up
like
from
to
the
sort of
manager's
frame
perspective,
for the entirety of
the waitress, the bar owner, the cook, the customer,
So,
right? They all have a model, even in the bar, even as a customer in the bluestone mill.
so
They're equal to each other,
everyone
congruent.
in here knows that atoms are made of
What would it be?
electrons.
Capital E in
particular,
parentheses X,
you know
right?
that electrons exist because you've seen a cathode ray
But
tube.
basically, that's to say derivative L over derivative S. Now, see how many models we just crossed through right there? And then have a conversation in the bar about work. Alright, so there's a lot of models. Now, I understand a lot of those models, and sometimes you got to make the divergent flow with a model to kind of defend yourself, to kind of... The best defense is a good offense, right? A good offense is a baller defense. Derivative L, derivative T in EX or FX or A parentheses X to a lower case. Sometimes you got to use those psychological triggers to help you kind of keep in line for what the page is once you get done with your first one. Even though I might do a bar, just the overhead floor schematics, floor movement, start tallying, systems, that's all management level stuff. That's obviously where that's going to go. I have all that done here. I might need to prime this. But remember, I can't, this is not a computer server. This requires you to hammer out all that information, test that system out, work through the processes on either multiple forms or some computer base where you can actually integrate when it comes up. And the longer the span is more realistically. Every once in a while you'll still watch documentaries on YouTube about space, and they say things like, what we can't explain from 6 years ago is down your throat, in your face, every second. The growth of the exponential growth of not just one person studying the material, but a lot of them. When you just had Newton, or you just got one brother in the mill or at the bar, it's the exponentiality of how nuclear that gets.
Secondly, nuclei.
But
we know that nuclei exist because you can shoot alpha particles, which come from radioactivity.
so let's take a nucleus differently. Let's assume that, without going crazy, me sitting in a bar or burning rock in a stone mill is a nucleus, and we can shoot protons at that. We can shoot electrons at that. Well, hell, we could shoot photons. But for the rules of congruency in mathematics, I'm not particular which way you go. This class requires the stone mill or the bar, or at least something that need to be separated in some functionable way. That way we're not just walking straight into some alcoholics, kids' problems with, whatever. And I'm not saying I'm alcoholic. I'm saying I got fucking social disorders and Yeah, no, it's just weird sitting in the room, especially when you're just going to graph everything 200,000 frames per second. Look at the movements, make decisions, play the hypervigilance. A little PSTD about situations are good. Remember, these are just terms. We're just applying it as a nucleus. We can enrich it with protons in a second in a system. I'm not saying that that's something you need to just go off the rafters for, cry wolf, and do all this other shit about your PSTD. It's not going to change, just to be fair with you. I'm here to help. They're there to help. Plenty of resources where we can study and do those things. So that would be one of the first places I put you.
These experiments that there are electrons and there are nuclei.
Okay, so let's take that a bit farther. Let's use this as their town map, Hancock again. Let's go back to there and pick this way apart. Now we know where the atoms are, business, right? Or at least that's how we'll play them in this class. Without him telling me it's E minus and N plus and everything else that's going to blow up our math. I'm not disagreeing. If I was in his class and we were working the material, that is perfectly goddamn fine. However, brother, I'm not working with those kinds of people, Alan, so I hope you understand. It's going to require a model for it and how to adjust that. Now, of course, I'm working the model without any real trial and error. It's not like I could talk to the manager behind there. And personally, remember, for me, everybody in the stone mill is doing something, and I study the management of that, which has time, space, systems behind them, and equally does so does the bar. And it's something you need to at least pay respect to really determine the gravity, FMA, terminal velocities of these systems shorthand with a dimensional analysis. She's working, it's busy, they come around on this one, 9 o'clock. Not going to happen, even in my fantasy damn land, right? And of course, any other sociology systems in the social engineering of that region, distances, timelines, and values are going to play triple point across these things, if not in a multi-Schrödinger world circumstances. That's why you shouldn't be afraid to talk about at least one of the equations, touch on the material in the stone mill. But equally, make sure you have one for a social effect, right? You want to make sure, hey, the spectrum of Dave, this is what Schrödinger's equation can look like. Well, what do you mean by that? Dave's over there doing that thing. And yeah, at the M2 level of that, he's still applying a spectrum of Dave while doing a job. Sometimes integrated with a force that I could mathematically say, maybe this old lady found the dildo in the dresser last night, and that's why he's acting that way today. It might not be true, but if the end result on that function still plays in the same way, well, there you go. So, I made the note about management training on my timeline. I got a video from Gustin's where I'm talking about the test for skid steers, and they take you out back. And meanwhile, other than the fact that it drives, you don't have cones. It's going to be a boulder. It's going to be a cliff off the edge that you're dumping the dumpster. And not once will they watch you do that shit. And all the tasks, so there's two different types, right? It's like every one of the tasks I have to do here have the Compton scattering on a Hubble's 45 of every Sophie star, blue hypermassive giant, neutron star, and black hole inside of it. But we're calling them electrons here, not that specific problem. It's when that specific problem equals positive or negative 1 that you could say in that field there's a scattering, there's a spectrum of what, when we're talking about something right now, that end result is nuclear, right? There's something in energy here we're not containing. It certainly feels like criticality in the demon cores going off. And it wouldn't matter where you're doing that. Remember, that's not a business situation. That's a home situation. That's a parent situation. That's a fucking dog situation. A lot going on. Remember, have your first one. Have your first one. When you've got that done and it pops in here, oh, that was that dog one about 3 o'clock in the morning, shit, shower, and shave, let the dog out. Or let the dog out, shit, shower, and shave. See how they're vastly different and lead to vastly different results. Well, that's something we've seen before, and it's something that we can quantify on that. And it's something that we can build that math problem off of. You can call that the Ricci tensor. You can call that field theory. GR, it would be... Shit, that's lost. GR 1 half, 1R, 1 over R,
This strategy of
QP, something, I forget what it is, 4 pi, whatever, 8 pi, whatever. You know, it's giving me an area of a quadrant. When you read pi in an equation, I want it's the area under a theta, either vertical or horizontal, which is an angle. It's there might be y, but within the approximation, sometimes I don't want to start with the first day on S&P all the way to 2020. That's a lot of snowflakes and cyclicals inside of there to determine how one thing passed all the way through this. And in order to do that, you have to generalize it. One, you'd get masked out. One, we'd have to talk about the day, every second, Larry drinking a cup of coffee, and it's too much, and you have to generalize what that stone mill or stone mills or business or P's look like. You know, obviously I know that this isn't the most comprehensive one for any of those stone mills or any business or landscaper maps that I've always done. I designed it that way intentionally. That way I just didn't have something completely done for those people. Remember, this is about that set this way. I'm trying to get benefit off of that by using these models to then increase this situation so I can get this from a safety position or a management position, bait the system without having it done, and not need to have somebody give me, oh, that's why you can't give me that management speech. I've run the models. I've seen that trajectory on those things. And, you know, when you actually value the test and you value votes and numbers and shit like that, this is where this starts to matter. If you don't, gravity believes in you whether you believe in it or not. So I just want to be clear with that kind of subject matter inside of here. So with those models, you don't need to be so empathic. You know, you don't need to necessarily be so emotional about these things. But we can certainly begin to idealize why it's fair to have an opinion and an X value about what I think somebody's going to do. What do I think I'm going to do? What do I think that, in specific, he's going to do? And they are very different things. When I said they, this is a wide margin of spectrums of things. When I said me, it still is a wide margin of spectrums of things that will have massive differences between terms if by the group state there, and equally like Alan here. And that would be a model. That would be this overall model, 1, 2, 3. You get the math equation, this equals this plus this, right? The electron, the photon, and the positron, or the P, the rho, the position. That position is a nucleus. That position, but it takes a little while to get used to that kind of thinking about that, because a lot of people don't actually have the mass to be able to handle this information. There's nowhere for in their system the electron to pop off into to say that would be the singlet state inside here for derivative L over derivative T that I can then input in this field theory equation and lead to a result in some way. And I can Bernoulli's the field theory equation with a real system now, and that is Mn congruent to how it affects any field, right? And if there was me and you in there, we're fishing, we're hunting, we're running, whatever. That's going to spread in waves, right? You know, just to sprinkle some stuff back in here. Well, they're all black body spectrums. They're all Hubble 45s with what the set is. A lot of the times I find that when you get to the Berkeley equation, infinity hot, infinity cold, or infinity large, the integral of infinity large and infinity small, at the atommost, these students in here define the smallest average in the positive form that if I try to graph every student here by name over this time test in Berkeley, that I should be able to tell as a student what I feel is the smartest student in the room and not be discriminated against that, because just by theory of numbers showing up in this class, I should be able to put at least the majority of these students in some order. They may not like it, but that's the nature of math when I say there are also columns and sections where the order is different. Different situation, vectors, tangents, slopes, integrals, derivatives. Maybe there's some differential. If that was the lead relative to in general, that list changes. If, just to add the third, trajectory, higher angle, more power, or the highest angle is going to get you here. The lowest angle with the same speed is going to get you here, but that ball, in approximation, might bounce out. If you increase the velocity on that thing but drop the angle, it can still have that 60-degree angle to 30-degree angle velocity, or distance, with a velocity that is greater than they originally shot with a lighter angle, but ground state is still there. We don't have the luxury of starting from zero space. We are here. We don't have that orbital function of falling as a satellite inside here, but that's often how it feels. You know, we're not necessarily dealing with any friction in the standard of traveling through the atmosphere of particles. It's kind of played off on a flat, curved, saddled surface, right? And we do that with area, especially trigonometry, SOHCAHTOA. They're not about triangles. Trigonometry is about circles and area, under curves, on theta. And it's a great little goat path, if you will, to be able to handle that type of information, because there's so many weeds on it. You know, you just walk in the stone mill, I know it's there, SOHCAHTOA, your ass in bleach, but the grocery store. Let's put that aspect up there. If it felt like you were in an acid tank right now, let's begin to start field theorying those equations with some value. See if we can diverge alternate paths with those systems. Hey, it's not something I'm going to put up with in my class. You have this. It's different. Catch you on the next one.